we have an example of, we got 4 sample problems, and these problems are going to be similar to the problems you're going to see on your test. The first one, you're going to be given 2 functions, and you're going to have to do an operation on the functions. So this is telling you what they want you to do. They want you to take and use the operation of subtraction. And if this is actually the same thing as f of a negative 2 plus a subtract g of a negative 2 plus a, and I like this way a lot better, but I mean, you have to know that they're the same thing. So what we're going to do is we're going to substitute negative 2a into the function of f, then we're going to substitute negative 2a into the function of g, and your 2 results, when you're done, you're going to subtract them. So your test is going to be like this. You're going to be given a problem, and you're going to have kind of a table here. One side is for the explanation, so kind of like Sage and Scribe, you're going to have to walk me through what you're doing step by step. Then the other side, this column for work, show mathematically all of your work. So let me try and give you an example of what would be 100% on your test. Alright, so I would just go first. And what we're going to do first, we're going to substitute a negative 2 plus a into the function maybe I can make this smaller, into the function f of a. There we go, that's better. So that's first move. So that one sentence tells me what your first move is. Your first move, if you do it with the work, you're gonna have this f of a, the function, is 4 times the quantity a plus 4. And the quantity a, this is what you're going to substitute in. So in place of that a, I'm going to substitute a negative 2 plus a. Okay, now the more detailed you are, the better. So maybe I'm going to go back here. On second, I'm going to, what's your next move? You're going to do all that distributive property addition, combine like terms. You're going to do all the kind of the arithmetic. So let's summarize that whole process by just saying this. Let's say you're going to simplify that expression. An expression is just a collection of add, times, subtract, letters, numbers. It's what this is right here. This is an expression. So simplify it. Your work is going to be, and again, the more work you show, the better. So if you show me this, if you show a negative 8 plus 4a plus 4, I'm going to follow your step by step. And it's not simplified yet because you can always combine like terms, and these two, this negative 8 and this 4, are like terms. So after you simplify it, you should end up with 4a minus 4. Okay. Now, I think I'm on to my third step. So I'll just number it like that. First, second, third. Third, what we're going to do is we are going to substitute a negative 2 plus a into the function g of a this time. So the rule for g of a is a minus 1. So I'm going to substitute in place of a, I'm going to substitute this negative 2 plus a. Alright, fourth. Simplify that expression. So if I simplify, if I combine my like terms, I'm going to have a negative 2 and a negative 1. So it's going to total be a negative 3 plus a. Maybe I'll try and put some lines on here, so I think it'd look a little better if this was all one line. So I'll maybe try and get some lines for you, because that might clean it up. Okay, then we have got step 5. What are we going to do next? 5th. You are going to subtract the function. You're going to subtract g from f. So you're going to subtract what we got for our g was this right here. You're going to subtract a negative 3 plus a from what we got out of our function f, which was 4a minus 4. And let's show the work. Maybe I'll change colors. So you're going to take what you got in f, which is 4a minus 4, and you are going to subtract from f, you're going to subtract a negative 3 plus a. Now this is where the tricky part is, because you need to subtract both those terms. There's two terms here. There's a negative 3 and there's an a. If you subtract a negative 3, that's the same as adding 3. And if you subtract a, it should look like this. And then 4a minus 4 plus 3 minus a, combine your like terms, you're going to end up with, what are you going to end up with? 3a minus 1. And that would be 100%. So if you did that, you get 100%. So you did it in pretty much 5 steps. Your work matches each step, and you end up at the right answer. Perfect. Okay, let's try one. I'm going to give you another set of functions, but this time, instead of an operation, I'm going to have you do a composition. And a composition, you're going to take it, substitute it into one function, and then whatever you get for that answer, you're going to substitute into the other. And again, this is rewritten as g of f of a negative 1 minus n, and I like that a lot better. So you're going to take this expression, negative 1 minus n, first you're going to substitute it into f, then whatever you get out of that, you're going to substitute into g. So let's start off. First, what are we going to do? You're going to substitute. You're going to substitute a negative 1 minus n into the function. Where are we going first? F of n? Okay, let's move number 1. Substitute into the function f of n. So the function is just a rule. Here's the rule right here. The rule says whatever you substitute, you're going to times it by 3, and then you're going to add 5. So whatever you substitute, you're going to times it by 3, and then add 5. And I am going to substitute a negative 1 minus n. Okay, step 2. What do we need to do? Second, we need to simplify that expression. So you're going to do your distributive property. You're going to end up with a negative 3, and you're going to do this, and you're going to have a negative 3n plus 5. So you're going to end up with, after you simplify again, you're going to end up with the negative 3n plus 2. Okay. Now, third, you are going to substitute this expression, this new expression, this negative 3m plus 2. You're going to substitute that into the function g of n. And let's show it with our work. So the rule for g says this: whatever you substitute in, you're going to times it by negative 2, and then you're going to add 2. So negative 2 times whatever I sub in plus 2, and I am subbing in a negative 3n plus 2. Step number 4, fourth. What you have to do is you have to simplify that expression. So distributive property looks like first negative 2 times negative 3n. It's going to be 6n, a negative 2 times 2. This is going to be a negative 4, and don't forget about the plus 2 at the end. So you're going to end up with 6n minus 2. And are we done? Is that it? Yes, that's it. Alright, the third problem, and these are all coming from your chapter review, so this is 13 on the chapter review. Let me move this. They want to know if the given functions are inverses, and this is from lesson 7.8. So if you use your notes, there's a list of those 4 steps that you got to follow to find an inverse. So 2 functions, g of x and f of x, are they inverse? Probably the best way to do it, and the fastest, is if you take one of them, and it doesn't look like either one of them is going to be much easier than the other. So if you just take one of them, so if I choose g of x, and if I find the inverse of g of x, and if that happens to be the same function as f of x, then the answer is yes, they are inverse. So here is my first move. Alright, number 1. I'm going to find the inverse of g of x. So that's my goal right there. Finding the inverse of g of x. And there's really not much work yet. But if I say specifically, you're going to have to tell me how to find you're going to have to explain how to find the inverse. So second, here's what I want to do. And again, it's better, the more detailed the better. It's better to work more and have a chance of getting 100% than to leave stuff out. So second, we are going to replace, and I'm just following the 4 steps, replace g of x with y. Now my work's going to show up. So my work is going to be y equals 4 minus 3x divided by 2. Alright, third, I'm going to switch x and y. So I'm going to have x equals 4 minus 3y divided by 2. Fourth, I'm going to solve for y. Solve for y, so I'm going to undo the negative 3 times y, the 4 plus y, and the divide by 2. So solve for y. Here's what we're going to do very first. We are going to times both sides by 2. So if I multiply this side by 2, and I multiply this side by 2, that's going to undo the divide by 2, so that's going to cancel with that. So you're going to have 2x equals 4 minus 3 times y. Now, the fifth step, we are going to subtract both sides by 4. So I'm going to minus 4 on this side, I'm going to minus 4 on this side, and you are going to have 2x minus 4 equals a negative 3y. Okay, we're down to step 6. Sixth, I'm going to divide both sides by a negative 3. So I'm going to divide this side by a negative 3. Now the left side has 2 terms. You need to divide both of them by a negative 3. So you're going to have this 2x minus 4 divided by a negative 3 equals y. And we are almost done. The last thing, 7th, you need to put the inverse notation. You need to replace y with, since it was g of x, I'm going to do g to the negative 1 of x. So I'm just going to erase this y and put g to the negative 1 of x. Okay, that means the inverse. Now this is kind of a tricky part. Is this the same thing as this? And the answer is yes. Even though they kind of look different, because this is a negative 2x plus 4 divided by 3, and this is 2x minus 4 divided by negative 3. They're the same thing. It's kind of like this idea. What is 16 divided by a negative 4? And the answer is a negative 4. But what if I switch the signs? What is a negative 16 divided by 4? Are these two the same thing? And the answer is yes, they're equal. So the only difference is your sign is the negatives on top, but down here on this one the negatives on the bottom. That's kind of the same thing that's going on here. They're the exact same thing, but the negatives just in a different place. So as long as your tops are totally opposite, so this is a positive 16, this is a negative 16, and your bottoms are totally opposite. This is a negative 4, this is a positive 4. So this one, a negative 2x and a plus 4x, the opposite of that has got to be a positive 2x and a minus 4x. And then the same at the bottom, your bottoms have to be opposites also. So 13 is yes, they are. Okay, the last type of problem that's going to be on your test is we're going to have to graph square root function. So remember, the function y equals x squared is going to look like a parabola, and the inverse of x squared, y equals square root of x, it's going to be a parabola, but it's going to be tilted sideways. So you're going to find the vertex, and then it's going to be that. But we are going to skip both roots. We're not going to find the plus and minus root of square root of x. We're just going to find the positive root. The negative root gives you the other half of the parabola, but we're not going to focus on it because it doesn't give us a function if we do both the top and the bottom. So we're just going to do the positive root. Alright, so you need to know what the general shape is going to be, and it's going to be kind of a sideways parabola. So if I know just by seeing the square root that it's going to be a sideways parabola, that's a huge start. Next, the best way to figure out the exact shape of it is just to make a table. Plug in some points, put in some inputs, and see what you get out. So what are we going to substitute in for x? Okay, now here's my goal. Underneath the square root, I'm going to try and make a 0. Then I'm going to try and make a 1. Then I'm going to try and make a 4. And then I'm going to try and make a 9. This one is probably the most important one, because this one is where your vertex happens. That's going to be the very first point of my parabola. So square root of 0. So I'm going to ask myself, okay, look at the problem, y equals square root of x minus 4. And that is all under the square root. This right here is where you're going to pay all your attention. You're going to ignore outside of the square root, you've got a minus 4, but you're going to totally ignore it. So underneath the square root, what could I substitute in to make it a 0? Whatever you substitute in, you have to subtract 4 from it. So if I substitute in for my x a 4, it's going to give me 4 minus 4 under the square root, and that is my 0. So square root of 0 is 0, and 0 subtract 4 is a negative 4. Okay, that is the smallest point you can plug in. You cannot plug in any point smaller than 4. If I try to plug in like a 0, I'm going to have the square root of 0 minus 4, and 0 subtract 4 is a negative 4, and the square root of a negative 4 is an imaginary number. So we don't want any imaginary numbers. We want our square roots to be positive or to have a 0. So I cannot go smaller than 4. But I can go bigger. So now I'm going to ask myself, okay, what would make it a 1? If I plug a 1 in here, how can I end up at my target to have a square root of 1? Because that's a perfect square. And I do my arithmetic in my head. What number subtract 4 is 1? And the number is 5. So if I substitute a 5 in, what's 5 minus 4? It's 1. What's the square root of 1? 1. What's 1 last? Subtract 4 from that. That's a negative 3. Okay. Then I know if I plug a 8 in, an 8 subtract 4, that's going to give me a square root of 4, and I love that because it's perfect. Square root of 4 is 2. What's 2 subtract 4? And that is a negative 2. So I'm going to have these 3 dots, and I just realized I should have haven't even been explaining it, haven't been writing it down. But this might be okay. This might be a good strategy. Do the work first and then go back and figure out how you explain it. So let's just finish with our work. Let's plot these 3 dots. If I go over 4 and down 4, 1, 2, 3, 4, you're gonna have a dot right there. To the right 5 and down 3 right there. To the right 8 and down 2. So your function is gonna look like this. It is gonna start at this one, and it's gonna move kind of up and to the right, and it's gonna have a curve shape, kind of like a parabola. Alright, so how do you explain that? Step by step by step. First, we want to find the smallest input. That's what we want to do. We want to find the very first, or the vertex, the first dot, the smallest dot. And you need square root of 0. That's what I need. That is my smallest dot. So you are going to plug 4 in for x. So the work, how are we going to show the work? Just show, I guess, this. Plug 4 in, so it's going to be 4 minus 4. Minus 4. Simplify it. I guess we can put plug 4 in for x and simplify. Let's put that. And then simplify. Let's do the arithmetic. 4 minus 4 is 0. Square root of 0 minus 4 is just 0 minus 4. So it's just minus 4. Okay. Let's say second. Plot the point 4 comma negative 4. Alright. And then you the work is going to be on the graph. I'll look on your graph. Plot the point on the graph. Now we're at third. I want now you can just tell me what you're going to plug in. So third, I'm going to plug 5 in for x and simplify. Oh, I should have changed colors. Alright, so if I plug 5 in, show me the work. You're going to have square root of 5 minus 4, and that is 1. So you're going to have 1 minus 4, and you're going to get a negative 3. So fourth, you're going to plot the point 5 comma negative 3. And then you just repeat it. The fifth step is going to be plug in 8 and simplify, and so on and so forth. So this one's not too bad. Now, just for fun though, if I were to change this, and if I were to make it instead of equals, if I were to make it less than or equal to, if we were to make it an inequality, then your answer could be a little bit different. You're either going to connect all these dots with a solid line or a dotted line, and then you're going to shade above or below. So let's just do this for fun. it would be, because of the equal to, it would be a solid line, so I'm okay. Now shade, do I shade everything above it or everything below it? And you can do it kind of logically without even testing any points. If you think of the y-axis is this one, the one that goes up and down. So the further you go up on the y-axis, the bigger the numbers get. The more you go down, the smaller the numbers get. So the y, or your output, your answer, is anything less than this function. And this function is represented with this line right here. So my answer is anything less than this line. And less than this line is anything smaller. So it's going down on the y-axis. So it's going to be anything underneath. But it's super important. You cannot go to the left of your vertex, because to the left of that point represents imaginary numbers. So anything less than is going to be under. Anything greater than is going to be above. And that sums it up. That's about it.